Hey everyone, welcome back to my channel. Today we are going to talk about one of the crucial topic for anyone who is going to build a robust and reliable application with Spring Boot with transaction. As you know, transaction having different types of propagation type. So that actually we are going to talk about in this tutorial. If you have ever wondered how Spring Boot manages multiple transaction methods calling each other, or how to handle scenarios like nested calls, suspending transaction, or even running without transaction. So these videos for those things that things I'm going to cover about different types of propagation types, that how it is working, why they do matters, so how like different types of properties basically work in a real times. So that I am going to cover in this tutorial with example. I am going to explain all the things that how we are going to use, when we are going to use, and how it help us to use in a better way. So in this video we are going to explore what each type does. Second, we are going to also understand when and where to use them. So let's also we are going to see some example. I will try to clear all the doubts over there. So let's without delay, let's just talk about all the details. If you don't have subscribed my channel, please subscribe for more tutorials like this. Okay, so next actually we are going to talk about different types of propagations. In my last sessions I have already covered that what are the different types of propagation type. Here I am going to talk about the details of it. As you know, Spring Boot provides 7 propagation type, right? So here if you see required, then required new, this required, then required new, supports, then not supported, mandatory, never, and nested. So these are the propagation types, 7 propagation type that actually we are going to use. This required one is the default propagation. That means if we are not going to defining any type for the propagations, in default it will take the required. So this actually what it will do, it will actually joins the existing transaction if there, or it will create the new one. The required new, what it will do, it will always create a new transaction and suspending the current transaction if already exists. The support actually what it will do, like it will play along if there is a transaction but doesn't mind if there is a no transaction. Okay, means if there is a no transaction is going on, then it will basically execute as a non-transactionally. Not supported means this is actually execute without any transaction. If is there any transaction is going on, then it will suspending the current transaction. Mandatory means it's actually must execute within an existing transaction, else it will throw an exception if none is exist. The never means it's actually keeps things strictly non-transactional. Okay, means actually there is a, in case of any exception is thrown, then it will not roll back the things, right? So this is the like never. And the nested means it will allow for rollback within a parent transaction. Okay, so these are the types of different types of propagation type. I will cover each steps in detail in later presentation. So let's going one by one. So first one is the required. This is the default one, right? So what it is, like let's say as I said, it is a default propagation type in Spring Transaction Management. It ensures that the transactional method always execute within a transaction, either by joining an existing one or starting a new transaction if none is exists. Let's, if we talked about that, if you are a part of some project and someone already like working on that particular project, right? In the meantime, in the middle of this one, you joined them instead of starting your own project, right? The similar kind of things actually done for this required. It's actually always use the existing transaction if it is available. If not, then they will create the new one. So this is actually a required one. So here if we talked about the if transaction is already active, the method will join and run within that transaction. So this is the main thing. If no transaction is active, then it will create the new transaction and then it will do whatever actually the necessary things for the transaction, then they will follow this one. So this is the key point for this one. Now if we'll talk about the use case of this one, so the for common transaction management actually we can use the required for most method when we want them to participate in the same transaction context for consistent data handling. Ideal for operations where multiple database queries need to be treated as a single atomic unit. Like any standard operations like creating an order, updating stock or processing a payment, then we can use this required, this default one. If no propagation type is explicitly specified, Spring uses required by default, right? When multiple methods with required are called within the same transaction, they all participate in the same transaction scope. If any part of the transaction fails, the entire transaction including all participating methods will be rolled back. Now I will show you some codes that how in a code basically we are going to maintain. So if you see, this is one service actually. Okay, so here if you see, this particular class actually annotated with the service annotation, right? And here this place order method actually annotate with this transactional annotation, right? This is the method, this transactional annotation method. So as here if you see, there is a nothing propagation type is maintained, so the default one will be the required. From this place order method we have called two method. One is the create order, this one, another one is the deduct stock. So now this create order, it's actually using this propagation is required. That means it will create the new transaction, right? Here actually one transaction is already started, so that's why this create order and the deduct order using this transaction instead of creating the new one. In case this particular method is failed, then the entire transaction including the create order roll back. This ensure atomicity, like all the steps will be either success or all the transaction will be failed, right? So this is the things, like when this place order actually method is called, then it actually start a new transaction if none is exist. Both like this create order and this deduct stock actually it actually join the same transaction context, right? If any methods throws a runtime exception, the entire transaction will be rolled back. So what is the benefit for this one? What will be the benefit, right? So the benefit will be consistency. It actually ensures all methods involved in the transaction either commit or roll back together. Means actually it's maintain the consistency of the transaction. Another benefit will be simplicity. Simplicity means it's actually suitable for scenarios when a single transaction boundary is sufficient. Obviously, as some benefits were over there, some limitations also over there. Like it's a tight couple, like all the methods using the required in the transaction are tightly coupled, and a failure in one affect all. Like suppose one method is getting failed, then other methods also be affected for this one. Then right, so this is the one thing. Even some kind of less control over there, like it's not suitable for use cases when we require separate transaction boundaries, like require new is doing the same job. So this kind of some limitations obviously over there. Now if we talk like when we are going to use this one, so this required actually when we want two methods to share the same transaction context for simplicity and consistent data handling, then we are going to use this required. So this is about the required propagation type in a Spring Boot transaction. Next, we will talk about that required new one. Okay, so this is the another parameter in a propagation we are using. So this required new is a transaction propagation type in Spring that ensure a new independent transaction is always started for the annotated method. If there is an already any existing transaction, then it will basically suspended while the new transaction is active. So let's say talked about someone in the group project taking a break to work on their individual tasks. So their work won't affect the group progress, right? So this is kind of things the requires new is doing. Okay, so if we talked about the behavior of this one required new, so actually it will, this method actually always run in a completely new transaction independent of any existing transaction. It actually suspend any existing transaction. If there is any active transaction is there, it will pause until the new transaction complete, right? So the same thing will actually define over here if we talked about the key points. Like this new transaction is isolated from the existing one, meaning changes in one do not affect the other. Independently commit or rollback. The new transaction commit or rollback independently of the original transaction. Suppose if we talked about some scenarios that when we can use, maybe if we are doing some auditing or logging. So ensures that logging or audit operations are committed even the primary transaction get failed. Let's say if we are doing some kind of order activities, due to some any reason, if something happened and it's got failed, then we store the data in an audit log, but the main transaction got failed, right? So in future it will help us to understand that what would be the reason to failure the order. So this can be the like scenario. Then it's actually if we want to avoid the propagations of rollback, it's a prevent a rollback in the parent transaction from affecting specific operations. Even there like login errors or sending notification when failures should not interrupt the main workflow. So these are the some common workflow where we are going to use this requires underscore new. Now we will see one example over here. So if you see that notification service here, similar kind of thing, like again this is used as a service one. Let me erase it. So if you see this particular class annotated with this service annotation here, and if you see this process order, it's actually annotated with this transactional annotation, right? So default is the required, means actually here the transaction is already started. Now this log notification method runs its own transaction. If you see this log notification, that means it's a propagation requires new. That means here it's actually create its own transaction, so it's actually not bounded with this transaction. Whereas this deduct balance, it's actually, if you see this is required, means it will actually joins with this transaction, right? So here if you see this one, so this is the thing that it will create the own transaction, means if somehow the log notification is failed, the main transaction like this process order, it continues unaffected, right? So that's why that log notification it will still continue if it is got failed. So this is actually useful for secondary tasks like logging or audit loggings. Okay, like here if you see this process order actually start the new transaction as the default behavior is the required. Then log notification annotate with the request new, that means it will create the new transaction. If deduct balance actually fails, the changes in save audit log, it will audit entry it's actually remain the unaffected, like this deduct balance or log notification will be unaffected. Now the benefit of this one, the benefit obviously it's a transactional independence, like changes in the request underscore new transaction are committed regardless of the parent transaction outcome, right? Then also it's actually ensure the critical tasks such as logging or notifications are completed even during failure. Obviously some limitations over here. What are the limitations? Like starting and managing a new transaction added over it. Obviously it will increase the complexities within when we are going to dealing with this multiple transactional context, right? So this kind of limitations we are having. Again, like I can say, like when we are going to use this one. So this requires new when we need to operation to be independent of the current transactions such as like critical tasks, logging, audit trails or notification handling, then we are going to use. If we need separate commit or rollback, like handling compensatory actions or avoiding parent transaction rollback. So these times these are the some scenarios, use cases where we are going to use this one. Okay, next we will see that supports. Okay, so this is another type of propagation types, is actually a transaction type in Spring that makes a transactional method optional, means it allows the method to participate in existing transaction if one is active. If no transaction is active exist actually, then method execute non-transactionally, means actually if there is any transaction is going on, then it will join the transaction. If not, then it will not, actually it will execute non-transactionally. So this is the type of these supports. So here if you see this participant in the current transaction is available, execute without a transaction if none is exist. So what is the use case of this one? Like if we want to do some kind of the read-only operations where transactions are optional. Suppose like if we want to fetch some data from the database, then we don't need to maintain any transactions, so that's why transactions are optional. Then we can use this supports, right? Like it's actually adapts to the transactional context in which it is invoked, right? Operate safety even no transaction actually exists. And if we talked about the like use case scenarios that I already mentioned, like if we want to ideal for the reading data that does not necessarily need a transaction, such as fetching static data or querying records without modifying them. Even sometimes where transactional behavior is beneficial but not mandatory, then also we can use this one. Some kind of utility methods that are called in both transactional and non-transactional workflow, then also we can use this one. Okay, now if we talked about the examples of it, like if you see this product service here, so here like this is again like as a service annotation over here. So this transactional annotation actually, like here again we have not defined anything, so default will be the required. And here this view product method, here if you see this is supports, so obviously it will join with this active transaction, right? So even if it is called from the this view product, if we call this from the outside of this class, then it will actually work as a non-transactional, because we are not calling that particular service from non-transactional method. As this particular method now in this example you called from here, again this class actually a transactional method, so that's why it will be support transaction. But if we call this particular method from outside of this class, then it will be work without any transaction, right? So if we talked about the benefit of this, like it's actually optimize the performance, right? Because transaction obviously it will take some time, but here it will avoid the overhead of transaction management when it is not necessary. It will actually reduce the complexities because it allows non-critical operations to proceed without enforcing strict transaction rules. Obviously, there are certain limitations, like without a transaction database consistency might be harder to manage. The absence of transaction might not provide rollback or data consistency in failure scenarios. When we are going to use this support type, like if we want to use the read-only operations like queries for fetching data that don't modify the database, then we are going to use, right? Another one, common methods that may be reused in both transactional and non-transactional workflow. Then also we are going to use if there is a performance critical sections over there, like scenarios where we are going to create a transaction would introduce unnecessary overhead, then also we can use this one. Next we will talk about another annotation, another type that is not supported. Okay, so this one actually, this not supported is a transaction propagation type in Spring that ensures the annotated method doesn't execute within a transaction, right? Means if we provide the annotation with not supported, means it will not execute within a transaction, it will work without transaction. If any transaction is active, then it will be temporarily suspended while the method runs. I am repeating once, if any transaction is active, then it will be temporarily suspended while the method is runs. Once the method is complete, the original transaction is resumed. Okay, so let's say you take a complete break from the group project and work on something unrelated, so that means it's a completely different. Okay, it's always runs outside of a transaction and suspended in case any existing transaction is there. So now the method actually will always run without a transaction. As I said, if parent transaction exists, then it will pause the duration of the method and then it will do the things. Commit or rollback mechanism are not available for this type. Where we are going to use this one, like report generations or any long running queries where transactions are unnecessary, right? Non-critical operations like tasks that don't require transactional support, as I said, like logging or maybe sending notifications, these kind of things. If we want to avoid the deadlocks, so then nested transaction or unnecessary locking where non-transactional behavior is preferred. Then if we want to like performance optimization, then it will basically useful for operations that don't need transaction overhead. If we talked about the examples for this one, then like we will see this one, that report service over here. Here if you see this transactional annotation with required, and here we are defining that not supported. Okay, so that means it will not supported any transactions over here, correct? So while fetching the data, so what is the benefit? It will basically isolation the transaction, like it will ensure that non-transactional operations don't interfere with active transaction. It will also do the deadlock prevention and boost the performance of the system. What is the limitations? Limitations will be like as it will not support the rollback, right? Obviously, limited use cases, these are the limitations of this one. When we are going to use this, like if we want to do some kind of logging, sending notifications or API calls that don't involve database operations. If we want to scenarios where the overhead of transaction management is unnecessary, then also we can do. If we want to avoid the side effects like prevent transaction rollback from affecting non-critical operation. Now we will talk about the another type, that is mandatory. This is another one, here this transaction propagation type in Spring that enforce the presence of an active transaction. The method annotated with a mandatory will throw an exception if no existing transaction is found at the runtime. Means suppose if we try to execute this mandatory without any transaction, then it will throw exception at the runtime. It doesn't create a new transaction under any circumstance. So like the method join the current transaction if and participate in it. If is there in no transaction, then it will throw the exception in the runtime. Like this method actually cannot run without pre-existing transaction. I am repeating once, this method cannot run without any pre-existing transaction. It never start a new transaction even one is needed. Okay, so that means it's actually invoking this method outside a transaction context leads a runtime error. So scenarios like when the method execution makes sense only as part of an already active transaction, then we can use this. Utility or share methods that assume transaction behavior from the caller, then only we can use this one. Critical operations where execution outside of a transaction could compromise data integrity. So these are the common use cases that we can use for this one. Now if we talked about this example, so here if you see this perform audit, actually it's over here. Here again it's a transaction, that means default is the required, here it's a mandatory. So if we call this particular method from outside of any non-transactional class, then it will throw that exception. Like calling this audit entry directly without an existing transaction, it will throw the exception. But as we are calling this from over here, then it will continue with this and it will not throw any exception. Okay. So this is for the mandatory. Next we will talk for this another entry, that is never. So it's actually never means it's refused to work if there is a already group of project, right? So throw an exception if a transaction actually exists. And we can use this one like tasks that much never involve transaction overhead, like cleanup jobs or sending matrices. So this kind of tasks basically we don't need to use the transaction, so then we can use this never. Now if we talked about the example of it is, so like here if you see that this one, like this transaction annotation, then this cleanup method actually having this never used, we have used here, and it will throws an exception because here actually transaction actually exists, right? So it's actually ensure the method remains transaction free, but here it's actually within transaction, then that's why like it will throw the exception because here one transaction is exist, because it actually doing the cleanup process. So once we are doing the cleanup things, then we don't need any transaction. Okay, next I think this is the last one, this nested. So this nested actually is a transaction propagation type in Spring that allows a like method to execute within a nested transaction. A nested transaction is a part of parent transaction, but it has its own independent save point. This allows partial rollback of the nested transaction without affecting the parent transaction. Okay, means if you are starting some kind of sub project within the group project, if the sub project fails, only its work is discarded but the main project continues, right? So this is the like concept of this nested transaction. Okay, so it's actually basically creates a nested transaction. If the nested transaction fails, it changes rollback, but the parent transaction remain unaffected. Okay, so if no transaction is active, nested behaves like required and start a new transaction. Okay, so that is also one behavior of this nested. Now here key points of this one, like a nested transaction creates a save point within the parent transaction. It's actually allowing the finer control over rollbacks. Dependency on parent. A rollback of the parent transaction rollback all nested transaction. Okay. Now nested transaction relies on the database save point support. Not all database support this feature. Okay. Use case scenarios for this, like when a failure is a specific part of the transaction, should not affect the overall transaction. Complex scenarios, like when sub operation need individual rollback capabilities but still depend on the parent transaction. Batch processing, here also we can use this. Now partial rollback within a larger transaction. Now if we talked about the example of it, like here if you see this, here two method, validate payment and the save payment details. So this validate payments, it support this nested one. Okay, and it is plain transaction, so that means it's actually having the required. So here if you see that process payment, when it start a parent transaction, that means it's a required. The save payment details actually run within this parent transaction. Okay, but validate payments is annotated with the nested. It's a created nested transaction. If an exception occur within the validate payments, it roll back only its changes while leaving the parent transaction unaffected. Okay, if the parent transaction roll back, all changes including the nested one are undone. Means all the will be rollback, revert. What will be the benefit? It's actually doing the partial rollback, flexibility, and also ensure that the data integrity. What will be the limitation? Like database dependency, it's also at the complexities and the parent dependencies. When we are going to use this one, like for the complex business process, in case of the batch processing, also for high data integrity needs. Okay, so now we will see some kind of the common pitfalls, like don't misuse this requires underscore new, because it will start too many transactions that can lead to performance issues. Neglecting the transaction rollback, because why? By default only the unchecked exception, which are the runtime exception, basically trigger the rollback. If we want to allow the rollback for some checked exception, then especially we need to mention those things using the rollback for properties. And also like propagation conflict, like combining mandatory or never with the inappropriate calls can break the workflows. So these are the common things that we need to follow over here. That's all actually for this one, and that's wrap up our deep dive into transaction propagation type in Spring. We have explored how these propagation strategies like required new, supports, and more actually give you more control over the transaction behavior in your application, right? From managing nested transaction with precision to optimize performance with non-transactional methods. These strategies empower you to build robust and scalable system while maintaining data integrity and consistency. Understanding when and how to use each propagation type is essential for creating efficient, fault-tolerant system. So whether you are working on a complex enterprise applications or optimizing microservices, these propagation types are your toolbox for your handling transaction effectively. If you found this video helpful, don't forget to hit the like button and subscribe for more Spring and Java content. Drop your questions on topics you would like to see next in the comments below. And as always, happy coding.